Hello, fellow puzzlers. I have Sabbado pyramids today. I'll have the place where you can print them out as well as the creators of the puzzles in the description below. Let's begin. I'll zoom this in a bit. Each orange triangle connects a set of 3 numbers. 2 numbers must add or subtract to equal a third. All numbers must be between 1 and 12, and no number can be repeated in a horizontal row. So I'm going to zoom this in a bit so I can write a nice size without having to scribble. And so, well, we can't have numbers repeating in a row like that. And when you do a triangle, it's 1 on the top, 2 on the bottom. And so to get to 8, it could be 6, which is 6 plus 2, or it could be 10 minus 2 to get to 8. And this one is kind of hard to get to absolute, so I'm going to start here at the top. And to get to 8, it could be 6, like I said, or it could be 10. If this is 10, then if this is 10, then these two have to add up or subtract to 10. So this could be 8, which makes no sense because this would have to be 0. Or this could be 12, which means this is 4, so this could be 7. Or this could be, I think it's only 7, because 12 and 3 gives you 9, 11 and 3 gives you 8. Yeah, so this has to be 7. Okay, and to get to 7, you'd have to have a 6 plus 1 or an 8 minus 1. So nothing really, and then if I put an 8 here, that would have to be 0. So we can't have that. So this has to be a 6. And to get to 1, this has to be 7. Well, this could be 9, but see, we have a double 9, so that can't be correct. So this has to be 7. If we do this one, it could be 1, or it could be 3. If it's 3, this could be 10, but not really, because 10 and 4 do not come near 2. Or this could be 4, which is, again, not good, so this can't be 3. So this has to be 1, which is 8. No. 6. Yes, that gives us our 2. So then if we go to this one, we can have 6, which makes this 0, which doesn't work. Makes this 10. To get to 10, we need 4, because you can't use anything else in this. You need 16, and you can only go to 12. So we can't put 3 here because these two don't go to 3. So this has to be 5, which matches up with the 4. Let's see what else we have here. We have 6 and 3, so this could be 9 or 3, but we already have a 3 here, so this has to be 9. See, 11, yeah, 9, take away. So let's see, to get to 8, here, we need 5, but we already have a 5, so we can't use that. 8, 9, 10, 11, so it has to be 11 to get to that. To get to 11, you need 2 with a 9. Okay, to get to 6, you can have 2. Yeah, that's the only way to get to 6 with an 8. So with a 9, you have to have 7 or 11. So if I put 7, let's see what happens. Oh, I already have a 7. So it has to be 11. 11 and 2 is 9, because you can't go over 12. And then you can't have 9 and 9 because that's 0. So something's wrong with my math somewhere in here. So maybe that's not 11. But there's no other way to get to 8 because 5 is already taken. Okay, so maybe this 10 is wrong. This 10 is wrong. Okay, so let's try 6. And let's see. To get to 2, we could put 6, but that's 0. So it has to be 2. To get to 2, that's 5. To get to 6, that has to be 8 because we already have a 4 and an 8. So this has to be 4, and this has to be wrong. So what do they have there? They have the 10. So to get to 2, make this 6. To get to 6, 4. To get to 8 is 6 and 2. To get to 6, it's 4 and 2. To get to 2 and 2, that's not right. You need a 0. So to get to 6, I could do 10. To get to 2, I already have 8, 12. 12 and 8 is 4. Okay, that matches up. To get to 12, I need a 9 here. To get to 10, I need a 1. To get to 4, I need a 5. And to get to 8, I can use a 5 or a 11. To get to 11, I need, this can't be 9. To get to 3, okay, to get to 9, this has to be 8. Or it could be 10, since I already have an 8 there. You can't have an 8 and 8, that means this has to be 0. So this has to be 10, and this has to be 2. Okay, and to get to 3, this has to be 7. To get to 11, it has to be 4. And I have no repeats, right? To get to 3, this has to be 6 or 11. No, 12. 6 or 12. Let's see what's going on here. To get to 7, I have to have 7. I have to have 5 or 9. I already have a 9 right there. So this has to be 5. And to get to 4 has to be 1. To get to 1, this has to be 8. To get to 8, no, to get to 9, 5 here, this has to be 4. To get to 2, 6. To get to that, 2 to get to the 8. To get to the 7, it could be 5 or 9, but we already have a 9. So it has to be 5. To get to 9, we already have a 4. Ugh. I need 4. Not working. Okay, let's go back. Say 6, but let's make it 10. To take the 10, we need a 3. To get to 9, we need a 6. Oh, actually, that's wrong. To get to 8, we need to get to 8. Wait, to get to 2, it could be 6, and let's try 2. To get to 8, you need a 6. To get to 7, you need a 1. To get to 9, you need a 7. No, you need an 8 or you need a 10. But we already have an 8, so that's a 10. And now, to get to 3, we don't have a 6 or 12. If we put 12, to get to 12, you need a 2, which I already have. So put a 6, you need a 4, which I already have. I already have an 8. Oh, wait a minute. To get this here, we didn't do this triangle here. That tells us what we need. Ooh, 8 to 11, 8, 9, 10, 11. So it's 3. So this can't be 6. How did I get 7 there? Oh yeah, because 8 to 1 isn't a 7. I can't use a 9 because we already have a 9. And this has to be 3. So this, to get to 8, we need a 10. To get to 11 and 1, 10. To get to this, to get to 4, 3 and 2 is not 9. To get to 4, I could do 5, but that doesn't help because it's still not 9. So I need a 7 or 11. And I have double 1s here, so I can't have that. This has to be 3. 4 and 3, I have to have 7. Okay, there was where my math was messed up. 7 and 2 is 9. And then I need 6 or 10 can go there, but we'll see. Okay, let's finish up this one. 7, this has to be 6. 9, this could be 12, so this could be 6. Oh no, this doubles up, I can't do that. Okay, get to 9 with, it has to be 12 here to get to 9. I can do 6 here and 6 here now to get to 12. This is 4, I don't have a 4. And to get to 6, I already have a 2. And I could put a 6. No, not a 6. I need a 2. 10, that's what I need. Okay, and then this could be 6. Alrighty, so I'm pretty sure that this is wrong. But let's take a gander. Let me zoom out so you can see. Come on, zoom out. Alrighty. So we have 2, 8, 6, 6, 2, 4, 4, 10, 12, 8, 5, 1, 9, 3, 11, 3, 2, 1, 10, 7, 4, 6, 9, 7, 8, 2, 5, 1, 6, 12, 3, 10, 2, 4, 9, 8, 10, 4, 8, 11, 1, 3, 7, 2, 6. Wow, actually got that right. See you next time.